So physics is the study of matter and motion. And in order to really dig into that, we've got to talk a little bit about some of the background to actually doing science. For science, you can have a model of something scientific or a scientific theory or a law, and these indicate how much data has been collected, how repeatable it is, um, and whether it's predictable. So models are used to represent complex systems. We'll be using models a lot to make things simpler, to work on the math and understand them. They are based on experimental data, and they do have limited accuracy. Your most experience with a model would be with weather. The weather guys get on there and use 14 different models, and one of them might be right for tomorrow, but it might not be. So that's kind of the idea of a model. A theory explains patterns in nature, and it's supported by evidence, and it's broad. Theory of evolution, theory of relativity. It's not focused on a single thing. And then laws are focused on something singular. So you've got Newton's law of gravitation. You've got his three laws for forces, where one of them, every action has an equal and opposite reaction. They're concise descriptions of a single action in nature, and they are based on experimental data, and they are repeatable. And so laws are pretty much, as far as we know, always true in some way. And then studying science, you have to do experiments. And so that brings up the scientific method. And you'll see a lot of different ways that this is presented. But basically, you will start with a question. You have to have some idea of what you think is going to happen and what you're watching for. So that's where you form your hypothesis. What do you think the answer to the question is? Create an experiment around your hypothesis and your question. Collect data and observations, analyze them, see if what just happened matched your hypothesis or not, and then see if it answered your question. If it didn't, go back, refine the process, and start again. And then lastly, just a real quick history of physics. The physics that we talk about today is not your grandfather's physics or your great-grandfather's physics. Started off as natural philosophy, people trying to understand how things moved, and these are big things. Stars, planets, and just rolling balls, things that are obviously big and in front of you. Why does the cart go down a hill? Why does the sun appear to move across the sky? How do the planets move in orbit? And then it moved into classical physics, which would be Galileo, understanding the planets, and Newton, understanding how objects move. Then we worked our way into radiation, bridging into the modern and quantum with Niels Bohr and Albert Einstein. And now we're into more of the modern pieces where we're trying to understand unified forces and string theory. And really very, very big ideas and very, very small particle physics. So it's changed a lot, and how it's handled has changed a lot. For this course, we're going to focus a lot on the Newtonian pieces, which is how the bigger items move, not at relativistic speeds. So it's going to be the things that you see, the things that you know, and the physics that explains a lot of the things around you. Bye-bye.